So our chapter is radioactivity. As we know that in an atom we have a nucleus in the center which consists of protons, which are the positively charged particles, and it also contains the neutrons which have no charge. Outside the nucleus we have certain orbits or shells in which the electrons are present. The electrons are negatively charged particles. While forming a chemical bond, it is the electrons which are taking part in the reaction, but the protons never take part in the reaction. But in our chapter, we will see how protons also take part in certain reactions. The protons are also lost from the atom. So initially, let us know the basics once again. So what is the atomic number and the mass number? Atomic number of an atom is the number of protons present in the atom. Although number of electrons and number of protons is same, but atomic number is defined always in terms of proton number, because electrons are lost during a chemical reaction but protons will never get lost during a chemical reaction, so its value remains constant. As a result, atomic number is equal to the number of protons. Mass number is what? Mass number is the sum of the number of protons and the number of neutrons. So if there are 2 protons and if there are 3 neutrons, then the mass number will be 2 plus 3, that is 5. So as you can see in the right hand side box, X is my element and A is the mass number and Z is the atomic number. The mass number is written at the top and the atomic number is written at the bottom. Now what are isotopes? You have studied about this in chemistry. Let's just revise it once again. Isotopes are atoms of the same elements having the same atomic number, but the mass numbers are different. There are many elements which contains isotopes, for example hydrogen, carbon, chlorine. So in case of hydrogen, you can see protium, deuterium and tritium. In all the cases, the atomic number that is at the bottom is same, it is 1, but the mass number is changing. For protium the mass number is 1, for deuterium it is 2, for tritium it is 3. Similarly, for carbon we have 3 isotopes, carbon 12, carbon 13 and carbon 14, out of which we will study about carbon 14 in the later parts of the chapter. So what happens that the proton is also removed from the atom or from the nucleus? So there are certain substances whose mass number is quite large. Whenever they are kept without applying any heat or without applying any temperature, they will start releasing certain particles. So the substances which disintegrate or decay means they are just releasing certain particles. They are not decaying like an organic substance by bacteria. This doesn't happen. Which disintegrate by the spontaneous emission of radiations are called radioactive substances. So from these substances, certain radiations or certain rays are coming out. These rays are actually composed of certain particles and they do not require any external heating or any external pressure. So these type of substances are known as radioactive substances. I guess you know about certain radioactive substances like uranium, polonium. There are also certain other names such as radium, thorium, etc. And this phenomenon of spontaneous emission of certain particles or certain rays from the radioactive substance is known as radioactivity. So we will study about 3 different particles or 3 different rays which are released from certain substances. They are the alpha, beta and gamma particles. So we are going to learn about them in detail. First of all, what are alpha particles? Alpha particles are actually the helium nucleus and they are positive in nature. As you can see in the figure below, helium atom consists of 2 protons and 2 neutrons inside the nucleus, and outside it contains 2 electrons. If both the electrons are removed, we have just the nucleus left with us. The nucleus contains 2 protons and 2 neutrons. So this nucleus of helium is known as an alpha particle. Now what are beta particles? Beta particles are actually electrons which are energetic, which have a high energy and they are negatively charged. Gamma radiations or gamma particles are highly energetic electromagnetic radiations. You have studied about this in the spectrum chapter of physics itself. So gamma particles are neither positively charged nor negatively charged, but they are very energetic radiations or rays. So alpha particles are positive, beta particles are negative, and gamma particles or gamma radiation has no charge. The speed of alpha particle is almost 10 to the power 7 meter per second. For beta particle, it is almost 2.7 into 10 to the power 8 meter per second, almost close to that of light. And for gamma radiation, it is equal to the speed of light because it is an electromagnetic wave. So it is 3 into 10 to the power 8 meter per second. So the mass of an alpha particle, as you can see in an alpha particle, there are 2 protons and 2 neutrons. Therefore, the total mass of the alpha particle is 4 into the mass of a proton, because we know that the mass of proton and the mass of neutron is almost same. So there are 4 particles together, so 4 into mass of the proton. For beta particles, since we know beta particles are electrons itself, the beta particles have a mass equal to that of the electron. For gamma radiations, it has no mass. Now talking about the charge, as you can see there are 2 protons in an alpha particle. So protons have a positive charge. As a result, the charge of an alpha particle is 2 into the charge of a proton, because there are 2 protons. Now talking about a beta particle, since a beta particle is an electron, so its charge will also be equal to the charge of an electron. And for gamma radiation, again it is chargeless. When alpha particles are exposed to electric and magnetic fields, for example, an electric field is there present around the alpha particle, or if there is a magnetic field present around the alpha particle, it will not deflect much. We will see about this in the next page. Beta particles will deflect a little more than the alpha particles, but gamma radiations will not deflect at all. Similarly, alpha particles can break into ions in a very high amount, but beta particles in a little lesser amount, and gamma radiation minimum, the least. Alpha particles can penetrate into only a very small space. It can move into a very small thickness, but beta particles can penetrate into a deeper distance. But in case of gamma radiation, since you know it is very harmful, it can penetrate throughout our body also. It is so energetic. Now, what substance can stop an alpha particle, or it is like a barrier to the alpha particle? Thin paper or human skin. That means alpha particles cannot enter our skin. For beta particles, it is lead and aluminium, quite thick, almost 1 millimeter or 5 millimeter of lead and aluminium. But for gamma particles, we have to use a 30 centimeter thick iron or concrete. That means gamma radiations can penetrate through a very huge distance. That's why in order to stop it, we require a very thick material. Now about biological damage. Since alpha particles do not penetrate into the human body, they cause very less or negligible damage. Beta particles can cause a little more damage, but gamma radiations cause the most damage because they can penetrate into the body. Now as you can see over here, in the first case, there is a magnetic field around the radioactive substance, which I have shown by a green ball, and an electric field also has been denoted in the picture below. The green ball is the radioactive substance. So what happens in case of an alpha, beta and gamma particle when they are exposed to a magnetic field? First of all, like we studied, the gamma radiation will not get deflected either by the magnetic or electric field. So it will pass straight. This is the gamma particles or the gamma rays. They will not get deflected. They will not move towards either of the positive or the negative side. They will pass straight. Now talking about the alpha particle, the alpha particles will move. They will try to move straight, but it will just get slightly deflected. These are the alpha particles. But in case of beta particles, always alpha and beta will move opposite to one another. Beta particles will get a little more deflected. So these are the beta particles. Now talking about in case of electric field, as you know, alpha particles are positively charged, so they will move towards the negative plate. So alpha particles, again, they are not deflected much, only slightly. So these are the alpha particles. Now talking about the beta particles, since beta particles are actually electrons, so they will move towards the positive side. They will get attracted towards the positive plate. So they will deflect very much. So these are the beta particles. So these two diagrams, which are given in your book also, you have to remember very nicely. So now as you can see, there is a black box outside. This black box is made up of lead. Why lead? Because lead does not allow the radiations to escape. So that we can see this deflection thing nicely. That's why the radioactive substance has been kept inside a lead box. So we are going to now learn what happens in case of alpha decay, what happens in case of beta decay, and what happens in case of gamma decay. In case of alpha decay, the mass number will decrease by 4 and the atomic number will increase by 2. As you can see in the examples below, uranium 238 and 92, the mass number is 238 and the atomic number is 92. So when it decays, when an alpha particle is removed from it or when an alpha particle is emitted from it, the mass number is decreasing by 4. From 238 it is becoming 234 and the atomic number is decreasing by 2. That means from 92 it is becoming 90. Along with that, since an alpha particle is actually a helium nuclei, see we have written helium 42. You can also write alpha particle, that is also okay. Similarly, for polonium, mass number is 210, but when it releases an alpha particle, its mass number is changing to 206. It is forming lead now. The mass number is decreasing by 4. The atomic number was initially 84, but now it has decreased by 2. So 82, from 84 it is becoming 82, and along with that an alpha particle is emitted. Now for beta decay, what happens? The mass number will not change, the mass number will remain same. Why? Because beta particles are actually electrons, and electrons have no mass, so no change in mass, but the atomic number will increase by 1. See the examples. Carbon 14,6, it is becoming nitrogen 14,7. The mass number is not changing, but the atomic number is increasing by 1. It is becoming 7 from 6, and electron is removed. You can also write beta particle. You can use that symbol also. Similarly, from uranium, we are getting neptunium. The atomic number is changing. It is increasing from 92 to 93, but the mass number is not changing. And along with that, an electron or a beta particle is removed. You have to mention which particle is removed. Now for gamma decay, no change occurs. Only the excited nuclei will convert into a stable nuclei. So the star mark, as you can see, that is for the excited nuclei. But later, when a gamma particle is removed, then it becomes stable. So no change in the atomic number and no change in the mass number, as you can see in the example itself. Now there are certain uses of this radioactivity, although it is harmful, but it also has a lot of uses. So what are the uses? Let's see. Isotopes of some elements which are radioactive in nature are called radioisotopes. I told you about isotopes in the beginning. So there are certain isotopes which show this radioactivity. They are known as radioisotopes. Certain examples are cobalt 60 and carbon 14. I told you about carbon 14 initially also. So what are certain uses? Diseases such as leukemia and cancer can be cured by a process called radiotherapy. In that case, cobalt 60 is used. Carbon dating, which is a process used for finding the age of old rocks or other archaeological objects such as coins and all, that is also done by using carbon 14. Also, certain isotopes of sodium, iron, etc. are used to detect the presence of a brain tumor or a blood clot. And gamma rays are very useful for sterilizing certain surgical instruments, bandages, etc. All the germs present can be removed or they will be killed when gamma radiations are given to them. Now what happens? These were the good things, but what are the disadvantages of radioactive substances? Radioactive fallout from nuclear power plants. Sometimes what happens in large radioactive power plants where radioactive materials are used to generate electricity or other energies, sometimes the fuel, which is uranium, polonium, etc., or sometimes the waste material, which are also radioactive in nature, they can come out of the nuclear power plant due to some accident. For example, breakage of the walls of the nuclear power plant or any other such phenomena. Nuclear waste, which is also radioactive in nature, or the nuclear fuel, which is obviously radioactive in nature, that might come out to the outer world and it can cause a lot of damages. There are 3 such phenomena which has occurred in the recent past. In USA it occurred in 1979, in Ukraine it occurred in 1986, and in Japan it occurred in 2011. You don't have to remember the years, but the names of the places where such nuclear fallout has occurred is important. So if such a situation occurs, people who are exposed to those radioactive substances can face a lot of issues. People can die, people can become crippled for life, people can lose their vision, people can get affected with cancer, many other detrimental effects. You all know about the effects in Japan after the nuclear explosion, the Hiroshima and Nagasaki incident. So the same thing happens if a nuclear fallout occurs. So if a person is exposed to nuclear waste, it can cause a lot of problems such as loss of hair and diarrhea. That happens immediately. And then cancer and leukemia can happen as a long-term process, and genetic defects can also occur. The person's DNA and RNA structures can get changed. Also, if pregnant women are continuously exposed to X-rays, they can develop cancer, and even their unborn child can develop cancer. So that's why nowadays X-ray is not used on pregnant women. So what are the safety precautions which can prevent such a mishap? First of all, whenever we are establishing a nuclear power plant, it should be located far away from the populated areas. And also the nuclear reactor where the processes are occurring, that should be shielded or that should be covered with lead and steel walls so that the radiations do not escape that portion. And also there should be a backup cooling system so that even if there is a problem, there is another backup to prevent any such accident. Now, for people who work on those radioactive power plants who are handling radioactive substances, they should always wear lead lined aprons. The aprons which they wear, that should contain lead, and also while handling those substances they should use lead gloves. Like I told you, lead does not allow the radiation to escape or move into. Also, whenever they are handling the radioactive materials, they should not touch it directly. They should do it with tongs made up of lead. Also, certain badges are worn by these people which gives the estimate of what amount of radiation they are facing. And also, these people are not allowed to work in radioactive power plants throughout their life. There are only a certain years for which they will work, so that they are exposed to least radioactivity. Also, whatever radioactive materials are being used, after usage they should be kept properly in a lead container so that radiations do not come out of it. After the work has been finished, whatever radioactive waste is generated, that also has to be disposed very properly, because it can cause a lot of damage otherwise. They should be first kept in casks or caskets which should obviously made up of lead, and then it should be buried inside underground mines which are specifically made for this purpose only. So we have to make sure that the entire process of nuclear energy generation is done in a very nice manner, so that people outside or the general mankind is not exposed to the harmful effects of it. Now, there is another term which is known as background radiation. Although we perform so many safety precautions while handling of nuclear waste and such, but we all are always exposed to certain radiations. There are two such sources. One is from inside, internal, and the other is outside. So internally we have a lot of ions in our body, or we have a lot of metals in our body which are radioactive in nature, such as potassium, carbon, radium, etc., which are present inside our body, in our bones, in our blood, etc. Also from external source, the cosmic radiation which is coming from the space, then certain radioactive elements which are found naturally, and also the solar radiations, they also provide radiation. But these radiations are such less in intensity that they do not cause any harm to our body. So it's completely safe.